I want to start off by saying good morning to everyone and thank you for having me today. My name is Georgette Jones. A little bit about my professional background. I've been in IT for about 17 years now. Started off in the help desk. I've done server support, project management. For the last 8 years, I have been administering storage area network and network attached storage. And today I want to briefly do an introduction to storage area networks, and hopefully by the end of the presentation you would have learned something that you did not know. A little bit about my educational background. I received a Bachelor of Science in Management Information Systems from the University of South Carolina. I have an MBA from Keller Graduate School of Management, and I'm currently pursuing a PhD from Capella University. So we're going to go ahead and get started here. So the first question, does anybody know what a storage area network is? Very similar to, and you'll see this as we go along in the presentation, very similar to some of the terminology is very similar to a LAN WAN network. So the definition of a storage area network, and the acronym obviously is a SAN. We refer that to as SAN, is a specialized high-speed, high-availability network that uses fiber channel technology to connect servers to storage disks. So don't get intimidated by fiber channel and all these big terms. We'll try to break some of this stuff down later on in the presentation. Some of the common SAN definitions: a node. A node is pretty much any device connected to the SAN. So your question may be, what type of device? Generally, a node is servers, tape drive, tape library. This can be a node on the SAN. It can be a Sun Solaris server, a VMware server. It could be Windows, pretty much any flavor, Windows, HPUX. There's a lot of interoperability in a SAN environment. The other very important definition is what we call a worldwide name. And the worldwide name is pretty much a unique identifier used to identify every storage device that's attached to the SAN. And this is generally 6 numbers. And you can kind of think of this as an IP address. And obviously, for reasons of troubleshooting, the first thing, people in the SAN world ask is, well, what's the worldwide name of the device that you're having a problem with? So that's how we storage administrators uniquely identify nodes and devices on the storage area network. And like I said, that's similar to a IP address. Fabric pretty much encompasses all hardware that connects servers and workstations to storage devices through the use of fiber channel switching technology. So the fabric is what encompasses all of the components that literally makes a SAN work. Fiber channel is a high-speed network technology used mainly for storage area networking. This is similar in the networking world. You can think about TCP/IP protocol. So what are some of the design considerations? Why would companies want to implement a SAN? Obviously, when you're looking at any type upgrade or any IT solution, it should solve an underlying business need. So your manager may come to you and say something like, our LAN backups are running very slow and we need better performance, or we're running out of data center. In our data center, we're running out of floor space and we would like to do some type of consolidation. Or we have this mission critical systems and data. We really need it on a high availability, high reliability type system, and SAN would be one of the solutions that you would probably look at. And the other consideration is obviously it should meet some business requirement for, like I said, availability and reliability of the data that you want to use it for. It should also be scalable to meet current and future business needs. Obviously, you don't have to start off with a huge storage array. There are different types of storage arrays to meet, small business, medium business, enterprise type businesses, and then you can obviously expand as your needs expand, and be cost effective and ease of manageability. Some of the benefits of a SAN: eliminates restrictions on the amount of data that can be accessed by an individual server as opposed to servers with direct attached storage. We'll look at a diagram here shortly. But there's also, a lot of environments still have a flavor of both of these. The SAN doesn't necessarily eliminate what we call the traditional way of doing things. It can work in tandem because most organizations put their, like I said, mission critical data on a storage area network. Storage can be accessed by multiple servers simultaneously with more robust and faster processing. So obviously, a direct attached storage can do the same thing, but allow multiple clients to connect to it. But the key here is robust and faster processing. That's what you're going to get from your storage area network through the fiber channel technology. Storage resources can be centrally managed, and storage space can be allocated and deallocated to hosts as needed. This is one of the great benefits of storage, that the direct attached storage doesn't give you that flexibility. So you can give this server here 1 terabyte, and then 6 or 7 months, this server gets decom, it goes away and is no longer used. You can put that 1 terabyte back into storage pool to be used by other devices on the storage area networks. Components are hot swappable, eliminating downtime. What I mean here by hot swappable, pretty much everything in the storage array is duplicate. Like, for example, the power supply, there's multiple two power supplies, 2 controller cards. Pretty much everything is duplicate for high availability. And hot swappable just means that if a part goes bad, it can be swapped without taking the storage array devices down or having to implement downtime if a part goes bad. And this is common practice for most of the high-end components now, and even a lot of servers, just normal servers also is similar to this. So what does a direct attached storage looks like? We call this DAS. So you can see here you have a traditional server. A lot of the servers obviously don't look like this now. A lot of the servers are actually blade servers, but I imagine there are some organizations that are still using what we call tower servers. So if you look at this application server here, you'll see that the disk are actually inside of the server, and you have this database server here. The disks are actually inside the database server, and you have these you have a print server. The disks are actually stored inside the print server. So you have all these clients. It could be Windows client, Unix client, Linux client. They're connecting to these various servers to access data, to access print services, access applications. So what happens when this server here fills up with space? There's no longer any more space in the server. One or two things has to happen. You have to either upgrade the physical server, or you're going to have to upgrade to larger disks, and all that depends on the limitations of the server. So, and then if you upgrade the disk, you got to figure out, well, how am I going to get the data moved off of the old disk to the new disk? And so you can kind of see how this model here doesn't have a whole lot of upgrade and scalability and flexibility. Pretty much when you max out this server, you're going to have to replace it. So this is what we call direct attached storage. So what components make up a SAN? The first component obviously is the server, and most servers look like this now. So this is the host, and it could be HPUX, any flavor of Windows, Sun Solaris, Linux. It doesn't matter. SANs are, you can put multiple type of host on the SAN. And every server must have what we call a host to bus adapter card. And you can think of this in the networking world as a Ethernet card. So every server has a host to bus adapter card, and these host bus adapter card generally has two ports. Either you have one card with two ports or you have two separate cards. And we'll see in a minute why this is necessary to create redundancy in your storage area network. And coming out the back of the host adapter card is the fiber channel cable. Remember we said the SAN uses fiber channel technology, and the fiber cable is what is needed to connect it to the storage area network, just like our Ethernet cable is what is needed to connect the server to a traditional network. So here we have fiber channel switches, and these are similar to routers. It's what routes the servers to the storage arrays to get to access the storage disk. And this right here is a redundant, what we call a redundant fabric. You want to, obviously a SAN can run with just one fiber channel switch, but you want to have two. So we'll see in a second how all this plays out. So you want to have two separate fiber channel switches, because that's two separate paths that's going to the same storage disk. So if one path goes down, you have an alternate route. And what does the routing is multi-pathing software. And you can see here, I'm showing EMC PowerPath, which is the preferable software for Windows host, but this software would obviously be dependent, the multi-pathing software would be dependent on the host. It would need to be compatible with the operating system of the host that you're trying to connect to the SAN. So every server must have the multi-pathing software, because if one of the paths goes down and the multi-pathing software is not working correctly, it would not be able to switch to the good path. And all of this is seamless to the users. One path goes down, the multi-path then automatically switches to the good path with no interaction from the administrator or anything like that. So here we have the storage array, and this can be, there's a lot of different vendors: Hitachi, HP, EMC. Probably there's a ton of different vendors that make storage arrays. So in any of these, you can have multiple vendor types, or you can just have a single vendor in your storage area network. And pretty much the storage array mainly encompasses disks. So you can see the DAS, the old way, you have a server, tower, or blade, and all the disk with the data that your users access is in that server. Here you have the server, but the disk is actually located in a storage array. So you can easily scale this and add to your storage array. You don't have to start off with 1 petabyte of data. You can start off with 2 or 3, for a small organization, 2 or 3 terabytes worth of data, and scale your way up as your storage needs grow. So like I stated before, like the DAS, the servers attached to a SAN have redundant connections to storage disks, i.e. data, via redundant fiber channel switches. And what the main goal of this is to eliminate single points of failures. So obviously the storage array is the heart of the SAN. Everything in here is redundant, hot swappable, very scalable. Also, you have fiber channel switches, and this is what makes the whole storage area network connectivity works. And you generally have two classes of switches. Two classes of fiber channel switches. You have an entry level, and these are normally departmental type switches. A lot of organizations put these entry level fiber channel switches at regional sites, smaller regional sites. They generally about 32 ports. And here you have your interlevel type fiber channel switch, what we call director class switch. You can see there's a ton of additional fiber channel ports, and these are generally used at the main headquarters because they're more robust. You're going to get faster performance. One other benefit of a SAN is that you can go to what we call LAN-free backups to eliminate network bottlenecks, because the LAN is much slower. So a lot of organizations actually use their tape libraries, put the tape libraries in the SAN, because you're going to get higher speed performance in your backups through the fiber channel. So you can see here, this little diagram shows a LAN-free backup using a SAN. The traditional way, the LAN, obviously, I don't want anyone to think that the SAN eliminates a network. A SAN is inside of a network. So every server in the SAN is also connected to, traditional network as well. But in the traditional backup world, you would have your backup servers, library connected to the network. You can actually move your tape library. If you look at this diagram here, you see your backup server is connected to the SAN, and also the tape library is also connected to the SAN. You're going to get much better performance in putting your tape backup solution in your SAN as opposed to doing your backups over a slower network connection. So here was what we have: a redundant fabric, and all that means is that every server, you can see, has two paths to the storage array. So we look at this HPUX server. It has one. Can you think of both of these fiber channel switches as separate SANs? So you have SAN A and SAN B. The HPUX box has a fiber channel connection, which is the purpose of the two HBA ports that we talked about earlier. HBA card having two fiber channel ports for redundancy purposes. So you have this HPUX box has one fiber connection going to SAN A, SAN B. The Windows, same thing, SAN A, SAN B. So if one of these connection goes down to SAN B, it also switches, the multipathing switches over to the good path, and there's no downtime at all, no interaction from the storage administrator. Same thing for this Linux box, has two connections. Tape library, the same things. Now the tape library doesn't really handle multipathing, because obviously there's no software that you put on it, but we still use two fiber channel connections here. The storage array also has two connections to SAN A and SAN B, because obviously if the SAN A goes down in storage array, the storage array doesn't have a connection to SAN B, the host would not be able to get to it. So this is what a traditional redundant fabric. Obviously there's some more complicated type SAN designs that we can get into, which would be a little bit more advanced. And also the storage management PC. So the storage administrator would sit wherever they sit. It doesn't matter. They don't have to be located where the SAN is located to manage the SAN, and that is done through tools depending on the storage area vendor. So if you have an HP storage array, they have their own tools to manage their storage array, and also EMC have tools as well. So the difference between a storage area network and direct attached storage, you're going to get more robust performance. It's scalable. it grows to your business needs. Direct attached storage also is connected to a traditional network, so you're not going to get as much performance. Storage area network uses a faster technology, which is fiber channel technology. So we just kind of touch on one of the main advantage of a SAN. It eliminates single points of failure, redundancy, performance, reliability, high availability. What example of nodes can be part of a SAN? You have tape libraries, VMware hosts, Windows, Sun Solera, HPUX. All of those can be different nodes on a SAN, and which is not a component of a SAN. Obviously, we talked about having to have a host bus adapter card in each server. And also you need a fiber channel switch to connect everything together. And an Ethernet card is not a component of a SAN. The Ethernet card is a component of a network. So if there are not any questions, we'll wrap up. My name is Georgette Jones, and thank you so much. I hope everyone learned something today. Thank you. And here's my contact information. If anyone has any additional questions or you think of something after this presentation, there's several ways to get in contact with me. Thank you so much.